Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 6 to 10 of the January 2018 Algebra 1 New York Regents exam. Alright, let's take a look at question 6. It reads, which ordered pair would not be a solution to y equals x to the third minus x? So we're looking for which ordered pairs does not satisfy this equation right here. Now, in order to check if an ordered pair is a solution to a function, all you simply do is you substitute the ordered pair into the function and you evaluate to see if you arrive at a true statement. Okay, so let's write that down real quick. Recall. To verify if an ordered pair is a solution, all you simply do is substitute and check. Okay, so that's what we're going to do here. We're going to substitute these ordered pairs into this equation and see which one gives us a true statement. Alright, so let's start with option 1. So for option 1, we have the ordered pair -4, -60. So what are we going to do with this ordered pair? Well, what we're going to do is we're going to plug it into this function, simplify it, and see if we arrive at a true statement. Okay? Alright, so this is the x coordinate, that's the y coordinate, and then our function is y equals x to the third minus x. Okay? Alright, so let's plug it in. For y, we have -60. Is -60 equal to x to the third, -4 to the third, minus -4? So let's work that out. -4 to the third is -4 times -4 is positive 16 times -4 is -64. So we have -64 minus times minus is a plus 4 -60. That's a true statement. So we eliminate option 1 because it is a solution. We'll move to option 2. -3, -24. We just substitute again. The question is -24 equal to what you get when you simplify -3 to the third minus -3? Well, let's see. -3 to the third is -3 times -3 times -3, which is -27. Minus times minus is a plus 3. Answer is -24. That's a true statement. Eliminate number 2 because it is a solution. Ordered pair 3, -2, -6. Let's see. Question is -6 equal to -2 raised to the third power minus -2? -2 to the third power is -8. Minus minus is a plus 2. Final answer is -6. We have a true statement. Eliminate number 3. So by elimination, option 4 should be the correct answer. This should be the ordered pair that does not satisfy this function. Okay, alright, let's see if that's true. Question, is -2 equal to -1 to the third minus -1? Let's simplify. -1 to the third is -1 plus 1. -1 plus 1 is 0, and that's a false statement. The answer to question number 6 is option 4. Alright, let's take a look at question 7. It reads, last weekend, Emma sold lemonade at a yard sale. The function p of c equals 0.5c minus 9.96 represented the profit p of c Emma earned selling c cups of lemonade. Sales were strong, so she raised the price for this weekend by 25 cents per cup. Which function represents her profit for this weekend? Okay, so let's go ahead and start by writing down our profit equation. So the profit basically is, so we have the formula profit is what you get when you subtract your expenses from your income. Okay, so the income is what Emma earned by selling the coffee minus the expenses, what she spent to get the operation active. Okay, all right, so we can further break this down. The income that she earns is by selling multiple units of whatever, in this case lemonade. So the income is generated by multiplying the unit price times quantity. Okay, unit price times quantity gives you the income, and you subtract the expenses, and you arrive at her profit. Okay, all right, now let's apply this formula to this particular scenario. We're going to look at before and after. Okay, so her initial unit price, so let's call that initial unit price, is, if you look at the setup that we have right here, we have um, P of C. Let's put it down here. So we have P of C equals 0.5 C minus 9.96. Okay, so we can see that her unit price, initial unit price, is 0.5 or 50 cents. Let's just call it 50 cents, or $0.5. The quantity is represented by the variable C, and Emma's expenses are given by 9.96. Okay, so what happened is that because of high demand for her lemonade, she increased the unit price by 25 cents. Okay, so the new unit price is going to simply be the original price, unit price 50 cents plus 25 cents. Okay, which is 75 cents or $0.75, whichever denomination. We're going to be using the dollar notation. Okay, all right, so with this information we can generate a new profit equation. So her new profit, using the formula that we stated here, is going to be, so it's going to be P of C equals the new unit price, which is 0.75 times the quantity C minus our expenses, which is 9.96. Okay, so we can clearly see that the answer to question 7 is option number 4. Alright, let's take a look at question 8. It reads, the product of the square root of 576 and the square root of 684 is, so is it rational or irrational, and what is the reason behind your answer? Alright, so let's check to see which is rational and which is not. So what we're going to do is use our calculators to help expedite the process. We're going to compute the square root of both numbers. If we end up with integer solutions, then that's rational. If we end up with decimal solutions, then it's irrational. Okay, so the square root of 576, every rational number written in simplified form does not have a radical. So the square root of 576 is rational because it is 24, an integer which can be expressed as the quotient of two other integers like 48 over 2 or 24 over 1. How about 684? Let's check this out. The square root of 684. Square root of 684 is a decimal, so it's irrational. Okay, so square root of 576 is rational, and the square root of 684 is irrational. So question, what happens when you multiply a rational number with an irrational number. So let's do a real quick review. So recall the following cases. If you multiply a rational number by another rational number, you're going to get a rational number always. Okay? Alright, what if you multiply an irrational number by an irrational number? Irrational times irrational is sometimes irrational. Other times it could be rational. If you have, for example, if you're multiplying two identical irrational numbers, you end up with an irrational number. But if you multiply a non-zero rational, because 0 is a rational number, a non-zero rational number, if you multiply it by an irrational number, guess what you get? A non-zero rational times irrational is irrational. Okay? That's the case here. So 576, the square root of 576 times the square root of 684 is irrational. Why? Because one of the factors is irrational. Okay? Because one factor is irrational. So the answer to question number 8 is option number 3. Alright, so let's go ahead and work out the entire problem so that you can see exactly what's going on here, okay? So the square root of 576, we computed that with a calculator, which is 24. How about 684? If we work that out, let's just break this down, okay? Let's take out 2. If you take out 2 from 684, you have 342. It's even, so you can take out another 2. If you take out another 2, you have 1, 7, 1. And then you can take out the digits. 1 plus 7 plus 1 is 9, a multiple of 3. So 3 goes into that. 3 goes into 171. 3 goes into 17 5 times. And 3 goes into, so you carry 2, 21, 7. Alright, does 3 go into 557? 5 plus 7 is 12, so 3 does go. So 3 goes into 5 once. 3 goes into 27 9 times. Okay, so identical factors that repeat, if you take the square root of them, you're just going to get one of them. So the square root of 2 times 2 is 2. And then the square root of 3 times 3 is 3. And then 19 doesn't have a factor to pair up with, so it stays behind. So the reduced form of the square root of 684 is 6 root 19. Okay. Now if you multiply 24 by the simplified form, 24 times 6 root 19, what are you going to get? You just basically multiply 24 by 6, so 6 times 4, 24, 4 carry 2. 6 times 2 is 12, plus 2 is 14. So you have 144 root 119. What kind of number is this? This is an irrational number because it has an irreducible radical component attached to it. So you can see that our answer is correct. Answer is number 3. The product is irrational because one of the factors is irrational. Alright, let's take a look at question 9. It says, which expression is equivalent to y to the 4th minus 100? So this is a factorization problem. Let's go ahead and refresh our memory on the formula for factoring difference of squares. Remember, all you need is for the exponent to be even in order to consider it a square. So let's say you have a squared minus b squared. The factored states involve just simply rooting the first and the last term and expressing the roots as a sum and difference. So this becomes a plus b times a minus b. We're going to employ this formula in factorizing, in finding the factorization of this quartic binomial. Okay, so y to the fourth minus 100. What we're going to do is take the square root of the first and last term and express the square roots as sum and difference. Okay, the square root of y to the fourth, let's do that on the side here. If you want to find the square root of y to the fourth, what you're doing is basically raising y to the fourth to the 1/2 power. Okay? And then if you use the power of the power property of exponents, this is y to the 4 over 2. And this is equal to y. 4 over 2 is 2. So anytime you're taking the square root of an exponential term, all you're doing is you're dividing the power by 2. Okay? So y to the fourth, the square root of y to the fourth is y squared. So we have y squared plus the square root of 100 is 10. Okay? And then that times y squared again minus 10. Alright, so just to help you see what's going on, this is a squared and this is b squared. And what I'm writing over here is a plus b. So it's subtracted from each other. A plus b times a minus b. So the answer is going to be option number 3, the factored form of y to the fourth minus 100, which is y squared plus 10, times y squared minus 10. Alright, let's take a look at question 10. It reads, the graphs of y equals x squared minus 3 and y equals 3x minus 4 intersect at approximately. So what we have here is a parabola and a straight line and 2 points of intersection. So to help us with this process, let's go ahead and use our calculator to facilitate the graphing process. So x squared minus 3 and the other one is 3x minus 4. Okay, alright, so let's go ahead and graph that. So what we're looking for is 2 points of intersection. Okay, so let's go ahead and find the first one. Let's see if we can determine it by tracing. So let's trace. So it's to the right. So it's 0.4. We can see that it's somewhere here, 0.4-ish. So 0.4 and negative 2.8. So if we look at the options that we have right here, we can eliminate option 2. Makes absolutely no sense. The other 3 points work, okay, because it looks like it's 3.8 and negative 2.5. How about the second point? Alright, so, well, we can also eliminate option 1 because it says only that point is the point of intersection. So eliminate that. Why? Because we have 2 points of intersection. Okay? So if we trace to the second point and look at, we can guesstimate what it is. It says 2.3 and 2.4. Let's move a little bit closer. Alright, so that's what it looks like. 2.6 and 3.5. It looks like the answer is option 3. But to be 100% sure as to what the exact answer is, we're going to use the calculate feature in the calculator to determine the exact value of the intersection. So press second function F4 to access the calculate menu. Go to option 5, which is intersect. First curve, enter. Second curve, enter. Guess, just move your cursor to a point close to the point of intersection. Enter. And it says 2.62 and 3.85. Our guess was correct. The answer to question number 10 is option number 3. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other tutorials such as this. If you have any questions or comments, just post it below, and we'll be glad to address it. More clips can be found on mathgotserved.com.